Woo! All right, you can see this as many times as you want tonight. You can just rewatch it over and over again. Yeah. If you want to hear something, say something loud. Like if you want to hear yourself later. Okay. That was you. Yeah. Yeah. All right. So before we go over the homework, I want to see if you guys can find the derivative of 3 over 2 times the cube root of x. You're going to have to rewrite it first. You got to rewrite it as a constant times the power of x. What happened to your pencil?
Oh,
Right
oh
there.
my God.
It was right in front of Jillian's face, for those of you that can't see. Who wants to tell me how to rewrite that? All right, I'm in. Right, 3 over 2 times x to the negative 1/3. There we go. Okay, so we haven't taken the derivative yet. We have to rewrite it. That's why I made you do that when we had that pre-calc review in the beginning of the year. Because now, to get the derivative, what do you have to do first? What do you do? Cameron? Yep, you have to multiply the negative 1/3 by the 3/2. And we multiply by, we just multiply across, unless of course we can cancel first and then multiply across, and we can, because 3 goes into 3 once. So what is negative 1/3 times 3/2? Negative 1/2, right? So your first step is you multiply the exponent by the coefficient, and we have negative 1/2. Then we write x. Now what do we do to get the new exponent? Right? Subtract 1, right? So the old exponent was a negative 1/3. When you subtract 1, you're going to write 1 as how many? 3 over 3. 1 is the same thing as 3/3. You have to write 1 with the same denominator as your original fraction. So negative 1/3 minus 3/3. Nice, negative 4/3. So that's our derivative. Now, we can rewrite that. We can have a little more fun with this before we get to the homework. So we have the negative 1 over 2. Now, the x is going to be in the denominator because the exponent's negative. Which is the root? The 4 or the 3? The 3. So it's the cube root of x to the 4th. Now, you see how that power is greater than the root? We could break that down a little more if we didn't want to stop, right? Sometimes you don't want to leave a problem. You know what I mean? You just want to keep going with it. Right? Kids are all saying, yeah, we hear that. So you could make this the cube root of, what's a perfect cube? X cubed, yeah. And then it'd be times the cube root of x. So you'd break it up like that, and then we could write our final answer as negative 1 over 2x cube root of x. Now that's a good looking answer. Oh, I'm sorry, let me move that up. All right, beautiful. Kids all agree that's beautiful. Okay, let's go over the homework. We're not that. One at a time. Now, the first one, he wanted you to take the derivative of x squared minus 6x plus 1. So you just 2x minus 6. You might not have understood the directions. What they wanted you to do after getting the derivative was plug in 0. So if you plug in 0 for x, you get negative 6. If you got the derivative was 2x minus 6, I'm thrilled, okay? So that one was kind of nice. How many people got the derivative on that one? Okay, cool. Now the second one, you can't just take the derivative until you rewrite it. You see? Because you have a power rule. It's not for 1 over x to a power. It's for x to a power. So you have to rewrite f of x. I drew it down here. 1 over x is x to the negative 1. minus 3 over x squared, minus 3x to the negative 2, plus 4x to the negative 3. You have to do that rewrite first, then we can take the derivative. Move this up a little. So now we can follow the rule. You bring down the exponent, so that's negative 1. You write x, and subtract 1 from the exponent. So you get negative 1x to negative 2. For the next term, we have 6x to the negative 3. Yeah. I would love it if you'd write it like that. In fact, that's the answer, the final answer you would want to write like this. But I'm showing you that, in order to get there, first you have to rewrite the function using your negative exponents, take the derivative of each term, and then when you're done, rewrite it without the negative exponents. How's that? Need me to go over any part of that? All right. Number 4. So you had to start by rewriting it as 8/3 times x to the negative 2. Now you can multiply the exponent by the coefficient. Negative 2 times 8/3 is negative 16/3. So you multiply, you write x, and then subtract 1 from the exponent. And guys, when you subtract 1, you go to the left one on the number line. So I know that positive 2 minus 1 is 1, but negative 2 minus 1 is not negative 1. A lot of kids do that. It's negative 3. Okay? Subtracting 1, you go left one. So yeah, we get a final answer of negative 16 over 3x cubed. If you didn't get it right and you don't understand what you did wrong or how to start, let me know now with these. I can slow it down for you. Anyone need me to? Don't be afraid. You can just introduce yourself with somebody else's name. Say, hi, and then say someone else's name and then ask the questions. I'm just Thomas. I don't understand anything. There we go. So, she's late, so she deserved that. Did you watch it? No. All right. Sorry, Jess. Okay. But that's what you can do. If you don't understand something, you're worried because I'm recording it, just do that. Okay. Number 5, again, you have to rewrite it. So before I can get to this answer, I have to rewrite it. I have to cube out the 3x squared. 3 cubed is 27. X squared cubed, exponents to exponents, you multiply them. That's x to the 6th. And you're still not even done rewriting it. That's negative 9/27, or negative 1/3 x to the negative 6th. Now you can take the derivative. You multiply negative 6 over 1 times negative 1/3. That gives you positive 2. Then you write x, and you subtract 1 from the old exponent. So the derivative is 2x to the negative 7th, or 2 over x to the 7th. Good times? We like this, I know. Okay, number 6. Oh, this is something. So this is what you were talking about that you didn't like. When you have a quotient, okay, I didn't teach you how to find the video didn't teach you how to find the derivative of a quotient yet. So what you have to do is simplify this. When you have x to the 3/2 over x, that's x to the half. Because do you guys remember when you divide, like let's use integral exponents, like x to the 5th over x squared, what that really means is x times x times x times x times x divided by x times x. And how many of those are going to cancel? 2 of them. So you'll be left with x cubed. So when you divide with the same base, you keep the base, okay, but you subtract the exponents. You take the exponent up here, and you subtract the exponent down there. So for me to simplify 6x to the 3/2 over x to the 1st, it's 6x, you have to subtract 3/2 minus 1. 3/2 minus 1, 3/2 minus 2/2 is 1/2. So that's what I had to do just to rewrite it. Now we can take the derivative. What's half of 6? 3. You write x. What's 1/2 minus 1? Negative a half. So you get the derivative, 3x to the negative a half, and you can rewrite it as 3 over the square root of x would be nice. But yeah. Get out of town. There's no other way to do it but my way. One way to do things in math.
I made the x on the denominator. I made it -1 and then I added the x.
Oh my gosh. So that's very smart. So they just wrote it as times x to the -1 and then added the exponents. When you multiply with the same base, you add exponents. That's smart. So I guess there was another way. Oh well. All right, 7. The first thing you want to do with 7 is just break it up. If the whole thing's over 3, you're just going to divide each term of the numerator by 3. So it's 4/3 x squared minus 5/3 x plus 6/3, which is 2. So you just rewrite it. Then you can take the derivative. So this one we're not going to have to rewrite because it's just 2 times 4/3 would be 8/3. So it would be 8/3 x minus 1 times negative 5/3 would be minus 5/3 x to the 0, which is 1. So just minus 5/3. But you don't have to whine over this one because it's the same thing. Because you don't know how to take the derivative of a quotient, you actually do the division first. So it's no longer a quotient. So every term of the numerator, you got to divide by the 2x. You know, and that might bother you. You might be asking yourself, wow, can you do that? Think about it. If you had fractions that all had the same denominator, couldn't you combine them? Right? So we're just kind of going the other way. So yeah, you want to break it up, simplify. So x squared over 2x, that's the same as 1/2 x. Minus 6x over 2x, that's minus 3. 2 over 2x would be 1 over x, or x to the -1. So all this work that we're doing is just a setup. Now we can take the derivative. The derivative of 1/2 x, the slope of the line 1/2 x, think of it like that, is always a half. The derivative of 3 is 0. And the derivative of x to the -1 is negative x to the -2. So again, we can rewrite it. So we had to divide every term separately, clean it up, then we could take the derivatives. How's that? You can do this. Are you ready? Getting tougher. We're getting tougher. Oh my gosh. Who remembered how to factor the sum of cubes? Be honest. Okay, a couple of people. How many people have never factored sum or difference of cubes that they remember? You didn't remember how to do it. So you know you did, you just didn't feel like doing it? No? All right, I want to review because, you know, until you know how to take the derivative of a quotient, there was no other way to do this. You actually had to factor the numerator, cancel, so that this function you would see is really just x squared minus 2x plus 4. Then taking the derivative is easy. If you don't remember how to factor the sum of cubes or the difference of cubes, I put it here to review with you. You know, with squares, you can only factor the difference of squares, right? But with cubes, you can factor both the sum and the difference. And it's actually not a big deal. I mean, the first factor is always just the same, what you see without the cubes, right? Yeah, and the second factor, you know, you always get the first term, whatever a is squared, the opposite sign for the product of the two terms, and then the last term squared. For both of them, I mean, you're doing the same thing. You write down the first factor, whatever's being cubed plus minus whatever's being cubed. And then you just look at this one, you square it, Opposite sign of the product, the last term squared. So for x cubed plus 8, x cubed plus 2 cubed, the first factor is x plus 2. If your x is your a, your 2 is your b. And then the x squared, the opposite of the product, minus 2x. And then the 2 squared, which is 4. So it cancels, and then it's a really easy problem, because the derivative of x squared minus 2x plus 4 is just 2x minus 4. I was just thinking you could have done some long division on that too. Right? That would have been another really good idea. The remainder would have been 0. You would have had that. All right, what else we got here? 9, 10. Okay, 10 might have looked intimidating, but there was no rewriting to do. You just go through term by term. So check that out. 4x cubed. And we just multiply the exponent by the coefficient. You write x and subtract 1 from the old exponent. What about that minus 2? What's the derivative of the minus 2? 0. Let's put it right here. Get that down. 11. This is another one of those. Before you're going to be able to take the derivative, you want to divide every term by x squared. So x cubed over x squared, that's x. Minus 3x squared over x squared, minus 3. Plus 10x over x squared, 10 over x, or 10x to the negative 1. Minus 5 over x squared, that's minus 5x to the negative 2. Then you can take the derivative term by term. You know, it's only if it's a sum or a difference that you can take the derivative term by term. And once you have the derivative, just rewrite it. Voila. Yes, Riley. No. No, it's just showing. Okay, 12. We don't know how to take the derivative of a product yet. Okay. So we had to multiply it out. So you just FOILed it out, which I did here. Kids at home. And then I combined. I had a negative 1x squared and a positive 8x squared, so that's positive 7x squared. So this is what y is when you multiply it out. And then you just take the derivative of each term separately. 3 times 2 is 6x squared. 2 times 7 is 14, and then x to the first. And the derivative of negative 4x would be 1 times negative 4 times x to the 0, or just negative 4. Yes? That is the, I will go crazy if you ever do that. If you do that with a quotient or a product, you better just watch out. You can't do that. Only with sums and differences. That, we are going to learn, though, the product rule and the quotient rule. No way. You took the derivative of this and you multiplied it by the derivative of that. That's one of these unfortunate lucky things that happen. It's so unfortunate because the kid will do something and it'll work and then think, okay, that's all I got to do. And it doesn't work in general. Let's say you took 2x plus 4 and you multiplied it by 2. 2x plus, oh, how does that equal that, though? That doesn't equal this. Wait a minute, so you did more than one mistake. Like you had a bunch of mistakes and you just got super lucky? Wow, you are a lucky guy. Yeah, it definitely does not work. You can see, guys, right? If you take the derivative of this, it's 2x plus 4. The derivative of that is 2. You multiply 2x plus 4 by 2. You don't get this. Okay? Always looking for a quick way. But that was good because now you can see that. So please, whenever you're taking derivative of a quotient or a product, we have separate rules for that. If you try to do just each piece separately, like we can do with sums and differences, you'll be wrong. Unless you're just really lucky. 13. You actually had to multiply by itself x minus 2 times x minus 2 times x minus 2. Multiply it out. So if you did multiply it out, I just have it the result here. Then taking the derivative is the easy part, right? So the derivative was nice and easy. It's just multiplying out the x minus 2. X minus 2 by x minus 2, that was a pain. 14 wasn't too bad. You just wanted to rewrite it, as x to the third minus x to the 2/3. Then when you go to take the derivative, what would the derivative of x to the third be? We have 1/3 x to, what's 1/3 minus 3/3? Negative 2/3. Okay, and then we have to take the derivative. We have minus x to the 2/3. We have minus 2/3. What's 2/3 minus 3/3? Very good. And then when you rewrite that, you get the answer. You have to know how to rewrite things. If it's multiple choice and your answer is not there with the negative exponents, you're going to have to find it and know how to do it. Yeah. But if it's just for me and it's just written out, I'm okay with just leaving it. Oh yeah, okay, so 15 was probably the worst one because first you had to square this out. All right, yeah, you had to multiply each, you'd write it next to itself, right? And you'd have to distribute. So each term in here, you have to write it as a product. So I did it, it looks horrible up here, but what I did was I circled all the x cubed terms in red, the x squared terms in green, and the x terms in blue, just so I could combine like terms. So when you square out the numerator, that's what you get up here. X to the fourth minus 2x cubed plus 5x squared minus 4x plus 4. But you're still not done, even after you square that out, because you still have to divide each term by x. That's going to bring down the power of x by 1. So you finally, if you divide each term by x, you get that. Derivatives, that's the easy part, right? You just go right through it. 3x squared minus 4x, good. Just 5, because it's going to be 5 times x to the 0. X to the 0 is just 1, so it's just 5. And remember, just think of a line, y equals 5x. The slope, the derivative, is always 5. 0 minus 4x to the negative 2. So that's how you get the derivative, and up here we just have the rewrite. Now you ready for a new rule? So far you can take the derivative of powers of x, constant in front of a power of x, 0. Oh, let's go through them, what we know, instead of me just saying it. All right, first rule we learned was the derivative of a constant. Constant functions are horizontal lines. What's the slope of a horizontal line? 0. So whenever you take the derivative of a constant, you get 0. So if someone says, hey, y equals pi, what's dy dx? 0. That's a constant. It doesn't change. It has a value assigned to it. I know some people see a letter and they think, oh, it's a variable. Nope. It stands for a constant. Second rule you have to know is the power rule. To take the derivative of x to a power, you bring the power down, you write x, and you subtract 1 from the exponent. Well, this is nice and easy after what you did. So what's the derivative of x squared? 2x. Done. Nice, right? And by the way, guys, every single one of these rules, they all come from the limit definition of the derivative. And it is in your textbook. I think it's chapter 3, section 3. It's either section 2 or 3. They have the derivations of every one of these rules. They didn't just come out of thin air. They actually used the limit definition of the derivative and showed all these. Now, I don't do that in class because it would take too long, but it really is from that limit definition. Okay, the next rule we learned was if you have a constant multiplier, you can just multiply the constant by the derivative. So if we rewrote x squared over 3 as a constant times the power of x, what would the constant in front be? So this is 1/3 x squared. If you have a constant in front of a power of x or in front of any function, you can just multiply the constant by the derivative of the function. We just do it all at once. So what would we get here for the derivative? 2/3 x, right? And the fourth rule, the derivative of a sum or a difference, and this is for sums and differences only, you're allowed to find all the derivatives separately and then add or subtract the derivatives separately, because this is only for addition and subtraction. Let's just rewrite this one before we take the derivative. So the first one, 3x squared over 4 is the same as 3/4 x squared. What about minus 1 over x? Minus 1x to the, good, and then plus x minus 7, that's no problem. All right. Now, what's the derivative of 3/4 x squared? Cameron? Mm-hmm. Right, it's 3/2 x, or 3x over 2, either way. Because 2 times 3/4 is 3/2. All right, next term. Plus x to the -2. What's the derivative of x? What's the slope of y equals x? Just 1, all right? Because that's x to the first, so it's 1x to the 0, or 1. And what about the derivative of 7? 0. So we don't have to write that. It's kind of goofy. So yeah, we would just write it as 3/2 x, or 3x over 2, either way, plus 1 over x squared plus 1. Four rules, death. I'm going to show you one more rule today called the product rule. Now, you are not going to have to do any homework tonight. I'm not going to do the quotient rule till tomorrow, because this was a lot to go over. But be ready for the quotient rule tomorrow. It's a good one. Let me show you how you find the derivative of a product without multiplying it out. This is what the actual rule says. To find the derivative of a product where one of the factors is u and the other factor is v, you take the first factor, you multiply it by the derivative of the second factor. dv dx would be the derivative of v, so derivative of the second, plus the second factor times the derivative of the first. You just have to say, like in words to yourself, and we're going to say it together a couple times. The first times the derivative of the second plus the second times the derivative of the first. I want us to say it together. Ready? So the first times the derivative of the second plus the second times the derivative of the first. Again, first times the derivative of the second plus the second times the derivative of the first. Some of you weren't saying it, so we got to do it again. Ready? First, Ernie, I'm watching you, times the derivative of the second plus the second times the derivative of the first. So you have to say these things in words, because when you're actually taking the derivative of the product, that's going to be going on in your head, and you'll do it. So let's take the derivative of this product. So the first is, this is the 3x minus 2, and the second will be the x plus 4. So I'll write it down here. What do I do? What do I put down? How do we start that again? First, what's the first? 3x minus 2 times the derivative of the second. What's the derivative of the x plus 4? 1. Then what? First times derivative of the second plus the second times the derivative of the first. 3. Right? Derivative of 3x minus 2 would just be 3. Let's clean this up. So I'll distribute the 1, you distribute the 3. How about that? So if we distribute the 3. So what do we get for this derivative, combining like terms? 6x plus 10. Nice. You multiplied it out first? That is the best question I've ever heard. You get a completely different answer. No, I'm just kidding. Let's do that. Ken, it's my video. All right, let's see if we can do this. No, that was like that was awesome because I want people to understand this is, these are just different ways of doing it. We could do it with the product rule and without. One you multiply it out, one you just use the product rule. See if you can do them both and then compare. For you kids at home, everybody's working beautifully. Multiplying it out, and they're just using the product rule. Compare it. I wish I could see like every single kid is working. It's amazing. And they look nice too. Alright, so that'll be it for this recording, because you can see that you're going to get the same thing. I hope you enjoyed this and are not upset that you are now responsible for it. Bye. How do I get that back? I was going to turn that thing off.